Let k equal 6 so that f of x is equal to 1 over x squared minus 6x. Find the partial fraction decomposition for the function f. Find the integral of f of x dx. And so let's first think about the partial fraction decomposition for the function f. So f of x, I could rewrite it where I factor the denominator. If I factor out an x, I get x times x minus 6. And so I can rewrite this as, and this is where I'm going to decompose it into partial fractions, a over x plus b over x minus 6. And if I actually had to add these two, I would try to find a common denominator, and the best common denominator is just take the product of these two expressions. So I could multiply the numerator and the denominator of this first term by x minus 6, and then the numerator and the denominator of the second term, I can multiply it by the denominator of the other one. So times x and times x. And so that would give us, let's see, if I distribute the a, it would give us ax minus 6a plus bx over x times x minus 6. X times x minus 6. If this looks completely foreign to you, I encourage you to watch the videos on Khan Academy on partial fraction decomposition. All right, so let's see if we can. So what we want to do is we want to solve for the a's and the b's. And so let's see. If we see that these have to add up to 1 over x times x minus 6. So these have to add up. I'm just going back to this. These have to add up the numerator. So it has to add up to 1 over x times x minus 6. And so this numerator has to add up to 1. So what we can see is that the x terms right over here must cancel out since we have no x terms here. So we have ax plus bx must be equal to 0. Or you could say, well, that means that a plus b is equal to 0. So we took care of that term and that term. And then we know that this must be the constant term that adds up to 1, or that is equal to 1. And so we also know that negative 6a is equal to 1, or a is equal to, divide both sides by negative 6, negative 1/6. And then if a is negative 1/6, well, b is going to be the negative of that. We have negative 1/6 plus b. I'm just substituting a back into that equation. Need to be equal to 0. And so add 1/6 to both sides, you get b is equal to 1/6. So I can decompose f of x. As being equal to a over x. So that's negative 1/6 over x. I just write it that way. I could write it as negative 1 over 6x or something like that. But I'll just write it like this just to be clear that this was our a. Plus b, which is 1/6 over x minus 6. So that right over there, that's the partial fraction decomposition for our function f. And if I want to evaluate the integral, so the integral of f of x, the indefinite integral, well, that's where this partial fraction decomposition is going to be valuable. That's going to be the indefinite integral of negative 1/6 over x plus positive 1/6 over x minus 6, and then we have dx. Well, what's the antiderivative of this right over here? Well, the antiderivative of 1 over x is the natural log of the absolute value of x. And so we can just say this is going to be negative 1/6 times the natural log of the absolute value of x. That's the antiderivative of this part. And then plus 1/6. You could do u substitution, but you could just say, hey, look, the derivative of this bottom part, x minus 6, that's just 1. And so you could say that, okay, I have that derivative laying around. And so so I can just take the antiderivative with respect to that. And so that's going to be 1/6 times the natural log of the absolute value of x minus 6. And then I have plus c. Don't forget, this is an indefinite integral over here. And then you're done. And you see that partial fraction decomposition was actually quite useful. So they were helping us how to figure out this. You didn't just have to have that insight. They're like, okay, how do I evaluate this antiderivative? Well, they're telling us to use partial fraction decomposition.